This is the statistics that all your parents, when they mail them out, fill out, report back, and they get statistics. They get data about Canadians and stuff. So anyway, according to this, 260,000 first people language speakers. The distance from Earth to the Sun is, how do you say that in English? 93 million miles. It's pretty close. The number of molecules in a gas, what's this say? Per meters cubed, or per cubic meter, right? 1 meter by 1 meter by 1 meter, that's a cubic meter, is, how do you say that? I don't know either. Thing is, math people are lazy, okay? That's a big number. We don't want to write all those zeros. So we invented a way to make it a lot nicer. We call it scientific notation. It's a way of writing numbers that are too large or too small to be conveniently written using all those zeros, okay? We don't want to do that. So in scientific notation, all numbers are written in this form. How many tens does this number have? Okay? It's a lot nicer to write it like that than like that. Because like I said, it's a waste of ink. Okay? N is an integer. It's a coefficient, if you will, and it's a number greater than or equal to 1, but less than 10. And in math terms, we can say that like this in that language. Okay? So, 32,000, let's start with something small. That's a number. To write this in a number greater than 1 but less than 10, we could write it as 3.2. And then you ask yourself, well, how many tens are there? All right, what do I got to multiply that by to get this? So I'll just show you. If I got 3.2 and I times it by 10, what does that do to the decimal? Moves it one spot where? To the right. Okay, I still don't have 32,000. I'm going to multiply by another 10. Now it moved the decimal once more to the right. I need another 10. 3,200. How many more do I need? Whoop. Oh, darn it. Let me start again. 3,200 times 10. Enter. There's 32,000. How many tens did I multiply by? 1, 2, 3, 4. So I can write that as, remember what we've been doing? And remember, like this is exponents, right? This is what we taught you. When I multiply with the same base, what do I do with my exponents? 1 and 1 and 1 and 1 is, so I can write that like that. Okay, so just to prove it, now how do you do that? Whoops. In your calculator, 3.2 times 10 to the power of 4. Bingo, that's the exact same number. Okay? Now 32,000 isn't that hard to write, but just as a quick exercise, we can still write that in exponential notation. Probably takes the same amount of time, right? It's really helpful when you got, like I say, huge numbers like that or really small ones. So let me just say, here's like the trick, okay? If this wasn't laid out in this big lesson, I mean, I wouldn't make you write down all these notes. That's why this workbook's really good, okay? I would just say, look, there's a number. How do I write that in scientific notation? I want it to look like that. I want this A, this coefficient, to be a number greater than 1 and less than 10. So boom, there it is. And then you count. Where's the decimal in 32,000? It's right there. Okay? But we just don't write it. It's understood. It's right there. So I would have to move it 1, 2, 3, 4 spots. So that's where this comes from. Okay? So you can think of it as multiplying it by powers of 10, which is correct. Or you can just, in the old days, this is how we used to teach it. So, standard notation. In other words, there's some number. Write it in scientific notation. I want it to look like that. how many tens do I need to multiply it by here?
4.
Here's your decimal. Let's count. 1, 2, 3, 4. Yes. Okay, so in other words, it would be 6.15 times 4 tens. And if you're a really quick learner, you would know, well, 32,000, that's the same size as 61,000, so it must be the same number of tens, right? Okay, how many more tens does this have? Good, but let's check. 1, 2, 3, 4, there's 5 tens there. And that gives me the exact same number. Don't believe me, put it in your calculator. It will probably show that. But if they get really big, you guys notice sometimes you do see this weird kind of times 10 to the, and then you go ask your math teacher, what the heck is that? Did I do something wrong? I said, no, it's just scientific notation, you just don't know it. Okay? So that's 5 times 5 tens. I'm not going to write that. This is a pretty small number, but if you want the mark on the test, if it asks you to write that in scientific notation, how many tens do you need to multiply that by? Good. You're catching on quick. So that's the same as 4.63 times 10, right? In other words, there's 1 10 there. Okay, going backwards. If I take that and I times it by 10, I get 28.1. If I times it by another 10, I get 281. To write it in scientific notation, how many tens do I got? 2. Good. How many tens do I have here? 1, 2, 3, 4, 5. Okay. Now we're giving you scientific notation. How do I write that in standard? How many tens do you have? 2, of course. So take that decimal and move it 2 spots to the right. Times it by 10, I'm going to get 92. Times it by another 10, I'm going to get 920. Okay, the decimal was here. 110, there's another 10, now it's there. Okay? We just don't write the decimal when it's after the 0 because it's redundant, right? It's like an X. We don't put the 1 in front of it, it's not necessary. Okay, let's jump from here to there. 1, there's 110, there's another 10, there's another 10, 1, 2, 3, 4, 5, 6 tens. Okay, let's double check. 1, 2, 3, 4, 5, 6. Check. Okay, if you want the commas, well, that's 1.4 million. That's how much Blake's going to make in his first 3 years of working, right, Blake? Oh, sweet. Okay, so complete this. Remember those big numbers at the top of the page? How many First Peoples languages speakers do we got in Canada in 2016? How do I write that in scientific notation? 2.6 times... Is it 5?
Yeah.
Let's double check. 1, 2, 3, 4, 5. Okay? Not too bad. No x exponents, no exponents of 3, no, just powers of 10. That's this lesson. That's it. Okay? 93 million miles. How many tens are in there? 1, 2, 3, 4, 5, 6, 7. 9.3 times 10 to the 7 miles. And if I was really nasty, I'd make you convert that to kilometers. Molecules in a gas. Oh boy, here we go. How many is that? I need 2.7. Anybody else check that? I'll trust you. Do we like 19? Yeah? Sweet. Now isn't that a lot nicer to write than all those zeros? Now what happens if I put that huge number in my calculator? 2.7 times, do you think it's going to show me all those zeros? No. It's just going to write scientific notation in a different form. Yeah, that says, don't worry about it. That says 2.7 times 10 to the power of 19. The E stands for exponent. Simply, it's short form for 10 to the 19th. There is an E button on here. Don't worry about it, okay? We're just going to want to do times 10 to the something. Lots of ways you can do the same thing, right? Oh, right. Projector cut out. Let me just try to connect it in once. Because it looks like I got 5 bars there. My wireless looks okay. There we go. Okay. Okay, so here's what you're going to do. Convert from scientific to standard. Okay? So move that decimal how many spots to the right? 7 times. 1, 2, 3, 4, 5, 6, 7. That's 3.8 times 7 tens. Okay? Pretty straightforward. Do we like this? Easier than negative exponents? Okay, we'll just hold that thought. We're going to get negative exponents in a sec. That's too big. I'm lazy. Okay? 2.9 times 10 to the 3, 1 10, 2 tens, 3 tens. And you know what? Don't even worry about those. Okay? We're going to pick our battles. I mean, you're not going to see that in chemistry or physics or something like that. Okay. Those were all big numbers. Now we're going to do small numbers. We're going to have to go the opposite direction. Because this still makes sense. An inch is 0.0000254 kilometers. Okay? Does that number ring a bell? 2.54? 2.54 centimeters is 1 inch. Right? But this is kilometers, so there's a lot more zeros there in front of it. Kilometers? Do you prefer? So let's go down here. This is a small number, okay? It's in decimal notation. I want to write it in scientific notation. So instead of multiplying by 10, to write this, I'm going to have to divide by 10. 110, if I divide it, okay? We'll bring a decimal there. Another one will bring it there. Another one will bring it there. And another one will bring it there. So I'm dividing by 4 tens, also known as, when you're multiplying with the same base, add your exponents. That's 10 to the 4. Remember, if I flip this up, it becomes negative. So that's the same as 6.3 times 10 to the minus 4. Okay? Oh, darn it, I missed the negative. 6.3 times 10 to the negative 4. Which just gives it to me like that. But if I go 0.00, just to prove it, 0.63, then this thing should give it to me in scientific notation, right? 6.3 times 10 to the minus 4. So you don't like it as much because it's a negative exponent, okay, but this is still what we needs to do. So just count backwards, okay? The decimal's on the left. It's a small decimal. I want 5.3 times 10 to the what? Negative 1, 2, 3, 4 spots, okay? And yes, you got a calculator. You can put this in and check. There is a scientific notation button on your calculator. Find it after, not right now. Okay? So this, I want the decimal here, after the 7. How many spots do I got to go in the negative direction? 1, 2, 3, 4, 5, 6, 7. Okay? And then that's the same as, you know, dividing by 10 7 times, okay? I'm not going to skip that, but here this is 2.9 times, it's over 10 to the 3, so if I bring it up, it's 10 to the minus 3, if I flip it, right? Reciprocal, that's the math word. And then, to write that, I want to move that decimal, how many spots? 3 spots to the left. So there's 1 spot. There's 2 spots, there's 3 spots. And then just double check it, right? Go backwards. 1, 2, 3, yep, that's the same thing as I have there. Okay. 7.1 dividing by 10, 1, 2, 3, 4, 5, 6 times. So move it 6 spots. 1, 2, 3, 4, 5, 6. Same number. Okay? Do I need to do any more? Let's do the last one. 8.5. I'm dividing by 10 5 times. That's the same as this. Okay, take that decimal, move it to the left 5 times. Once, 2, 3, 4, 5. Okay, double check before you move on to the next question, make sure it's right. Again, you can use a calculator. Okay, a couple examples above. Let's do that one. Is an electron heavy? Do you think that's like a massive object? Do you know how many electrons are in this room? Wouldn't even want to try to count. So that's the mass of an electron in grams. Okay, that's a lot of zeros. 3, 6, 9, 12, 15, 18, 21, 24, 27, 28. Why? 9 times 10 to the minus 28 grams. Here's a question for you. How the heck did someone figure that out? It's not like you can just like take one and put it on your bathroom scale, right? Hold that thought. Like, people have done this, and I'm not talking like 10 years ago. I'm talking hundreds of years ago, before there was even electricity. Someone figured out the mass of an electron. Google it. Okay, just let me finish and I'll give you tons of time to work on this, okay? Why is that not scientific notation? Because this is not a number between 1 and 10. Sorry, that can't be there, okay? So in order to make it scientific notation, I need to move that decimal after the 4, right? So does this become minus 7 or minus 9? It's kind of tricky, right? I have to think about this. Okay? Because to get from here to there, I got to go one spot in the negative direction, right? Okay? Kind of tricky? You remember you got a calculator? 0.4 times 10 to the power of negative 8 is 4 times 10 to the power of negative 9. Okay? To go from here to there, I have to move that once in the negative direction. So a little tricky, right? Okay? And, well, that's what I just did right here. So, quickly, you do have a scientific mode on your calculator. It's a different spot than this calculator, so there's no point in me going over all this, because I don't think, actually, one kid in the class has this calculator. And EE is another way to write times 10 to the, times 10 to the some power, okay? Exponent of something, but not even going to go there. It's not worth it, because again, you don't have that calculator. Last thing, this is easy peasy. Just put that in your calculator, multiply them, and if you're in scientific notation, it'll give you an answer in scientific notation. Okay? So this is just a calculator exercise, not much thought here at all. Put it in properly, get the answer. So you'll get a couple of these too. In the old days, we used to do this by hand, but hey, you know. 9.1 times 10 to the 14, okay? And in this case, was that just this times this is 9.1? 10 to the 5th plus 10 to the 9 is 10 to the 14? Yes, but it doesn't always work that nicely, okay? Quotient, well, you just divide, but same thing on your calculator, okay? No point in me putting that in and showing yous. That's it. Scientific notation. Who plans to go to chemistry? That's not many of you. Or physics. Well, I guess you got to wait to see what kind of a mark you get in Math 10 first, huh? What's chemistry? Study of molecules and matter. But that's actually physics a bit too, isn't it? Okay, you bet. Physics is the study of matter, energy, and how they interact. That one I'm good at.